Hello everyone. So far I have completed module 1. So from this class onwards I am starting module 2. So what is this module 2 and what are the contents you are going to study and what are the syllabus and what are the subjects you are going to study in module 2. This module 2 is completely the study of petrology. What do you mean by a petro? Petro is nothing but rock, the study of rock. Before studying this module 2, why you have to study and what is the importance of studying this petrology? See, we all know that the rock is the essential component for any civil structures. Where that rock has been used, this rock has been used for foundation, roofing, cladding, flooring, etc. See, for foundation, what you require? You require rock. For the flooring, what you require? You require a rock. And again, roofing, what you require? Again, a rock. A cladding, what you require? Again, a rock. We all know that. What is that rock? Commonly, you used to call a granite rock. Or commonly you used to call marbles. When you go to commercial places that is like granite showroom, you used to ask, you need different types of granite. What is that granite which has been made up of? That is a rock. Okay. So in this petrology, in this rock, we all know that it has been divided into 3 categories. The rocks has been having a 3 types. That is igneous rock, sedimentary rock, and metamorphic rock. There are 3 types of rocks: igneous rocks, metamorphic rocks, and sedimentary rocks. So I have explained what is the uses of these rocks, and these are the 3 types of rocks. Now let us start from the igneous rocks. Okay, what do you mean by igneous rocks? Where it forms, that is the important thing. See, igneous rocks is nothing but ignes. It is a Greek word. Ignes means a fire. Igneous means a fire. This is the source for having the rock structure. How it is so? See, you just consider right here. This is igneous rock. How it forms? You assume this is a earth surface. This is a earth surface. What happens in the earth surface? Automatically, beneath the earth surface, there is a chamber called magma chamber. There is a chamber called magma chamber. This magma chamber beneath of 70 to 100 kilometers in depth. Okay. What is this magma chamber? This magma chamber is being made of liquidus in nature. That is solution. That is solution. The magma chamber that is beneath the earth surface, which is of liquidus in nature, that is liquidus or solution. Again, what is that solution is being made up of? Again, this solution, this might be the solution, whether it is an acidic or basic solution. Acidic or basic solution. The magma chamber, which is been made up of liquidus in nature, that solution is being made up of acidic or basic. Then what is the temperature of this solution? Usually this temperature of this solution is 900 degrees Celsius to 1800 degrees Celsius. See, we all know that the litho is what? The rock structure, that is the hard substance. Beneath the surface, the chamber which has been present, that is a magma chamber. How that chamber, what is that chamber which has been made up of? Acidic and basic. Okay, so it is completely, that solution will be in the boiling point. That boiling, that's why this igneous rock, igneous means fire. What do you mean by igneous? Igneous means fire. Why it has been called as fire? Because the temperature is 900 degrees Celsius to 1800 degrees Celsius. So that solution which has been made up of acidic and basic, that will be in the boiling condition. See, when it is in boiling condition, when it tends to cool, what happens when it tends to cool? Automatically, the temperature will be of around 600 degrees Celsius to 1600 degrees Celsius, or somewhat vice versa. Automatically, what happens? This temperature tends to cool to form a solidus substance, that is solidus. That what we call it as liquidus to solidus, that is what we call it as igneous rock. See, earlier beneath the earth's surface there is a magma chamber. That magma chamber is completely made up of solution in nature. That solution consists of acidic and basic. The temperature is of 900 degrees Celsius to 1800 degrees Celsius. When it tends to cool, it starts to solidify. When it solidifies, that's what we call it as igneous rocks. This is how which is being formed in the earth. That is the igneous rocks. So now let us see the occurrence of igneous rock. Occurrence of igneous rock. Occurrence of igneous rocks. See, I will keep this figure as it is. This is earth surface. We all know that how the igneous rocks has been formed. The igneous rocks has been formed beneath the earth surface. When it is the cooling of magma, automatically it tends to cool, it solidifies. In the occurrence, again it has been subcategorized into two parts. What is that? Intrusive rock and extrusive rock. Okay, what do you mean by intrusive rocks? See, this is the earth surface. When the magma chamber tends to cool and solidifies beneath the earth surface, means this solution converts to solidus. That is whatever the activities which is been going beneath the surface, that part we call it as intrusive rocks. Intrusive rocks in the sense, we all know that beneath the earth surface there is a rock body. There is a rock body. How it forms? The magma chamber tends to cool and solidifies whatever the activities which is been going on beneath the earth surface, that is called as the intrusive rocks. Again, in the intrusive rocks, it has been categorized into two parts, which is that hypabasal rock and plutonic rock. See, this intrusive rocks has been subcategorized into hypabasal rock and plutonic. What do you mean by plutonic? Plutonic is nothing but the rock which is been formed greater depth, means might be at 100 kilometers depth. It means it will take its own time, because whatever the rocks we are seeing, in the surface, and whatever the rocks we are seeing in the hillocks or whatever, it will takes, the igneous rocks takes thousands of years to solidify. Minimum of 100 years to thousands of years it will take to solidify. It doesn't means the rock cannot be able to form within a day or within a month or within a year. It will take 100 to thousands of years. So the plutonic rocks means it will forms at a greater depth. Means, say for example, the temperature would be of 1500 degrees Celsius. What would be the temperature difference? It might be the temperature difference of 100 or 200 degrees Celsius. When it is of 100 or 200 degrees Celsius, it will take its own time to solidify and cool. When the rock will be formed at a greater depth, at a greater duration, then that rock is called as plutonic rock. Hypobasal rock is nothing but, say for example, this will also forms beneath the earth's surface, but it is near to the earth. It is greater to the earth's surface, we call it as plutonic rock. When the earth's surface, when it has been near to the earth's surface, the magma chamber tends to cools. Automatically what happens? The duration will be shorter compared to the plutonic rocks. Then it is called as the hypobasal rock. It is called as the hypobasal rock. Hypobasal rock is nothing but it is also forms under the beneath the surface, but it is forms near to the surface. The cooling rate and the duration would be lesser compared to the plutonic rock. Then coming to the extrusive rock. What do you mean by extrusive rock? See, when the magma chamber squeezes out to the surface, and automatically it will be flow towards to the towards to the any direction towards to the slope. How it squeezes? Automatically, this is we call it as vent. Vent is nothing but the space to erupt. Space to erupt. That vent is called as volcanic vent. That we call it as volcanic vent. See, in the magma chamber, when the pressure creates, automatically what happens? That magma chamber will erupt towards to the surface. This is what we call it as the volcanoes. When the volcanoes erupt to the surface, automatically what happens? We used to see in some of the videos or in some of the animated things, the liquidous solutions will come. What are the solutions comes? That comes liquid, sometimes solid particles, and also gaseous material. So in the magma chamber, when it squeezes, it comes liquidous, gaseous and solidous particles. When it comes, what happens? Say for example, earlier I was telling the temperature would be 900 degrees Celsius to 1600 degrees Celsius or 1800 degrees Celsius. When it is coming out, what would be the temperature in the earth's surface? The maximum temperature would be of around 75 degrees Celsius. Maximum temperature. The minimum, let it be minus degree, whatever it might be. When this magma chamber erupts, that is as in the form of volcanoes, what happens? It will cools rapidly. It will cools rapidly. It will cools rapidly to form the solidation structure. That is what we call it as the extrusive rock. The extrusive rocks is also called as volcanic rock. So, in this class what I told, what do you mean by igneous rocks? Igneous means what? Fire. Why? How it is fire? Beneath the earth's surface there is a magma chamber. In the magma chamber, that is solution in the origin. What is that solution which is been made up of? Again it is acidic and basic. Okay, when it is tends to cool, it solidifies. When it is solidifies, what happens? The igneous rocks will form. The occurrence of igneous rocks. In the occurrence of igneous rocks, again there is two parts, two types: intrusive rocks and extrusive rocks. The rocks which is being formed at the greater depth, what we call, that is plutonic rock. The rock which is being formed near to the surface, what we call, that is hypobasal rock. When the magma chamber squeezes out to the surface, through the volcanoes, as in the form of volcanoes, what happens? Because due to the temperature in the earth's surface, that maximum temperature what we are receiving is 65 to 75 degrees Celsius, that is in the desert, what I am telling. So when it cools rapidly to form a solid structure, that is rock, that is we call it as the extrusive. The occurrence of igneous rocks is two types, that is intrusive rocks and extrusive rocks. Again in the intrusive rocks it is going to categorize hypobasal and